There are three different types of triangles according to their side lengths. The first type is a scalene triangle. And that's a triangle where no sides are congruent to each other. So all three sides have different lengths. The second type of triangle is an isosceles triangle. And in an isosceles triangle, we have at least two congruent sides. And the third type of triangle is an equilateral triangle. And in an equilateral triangle, all three sides are congruent. Next, we can classify a triangle according to the angle measures. If we see in a triangle that all three angles measure less than 90 degrees, then we have an acute triangle. So let's say this angle was 55, this angle is 75, and this angle is 50. We have three acute angles. So we have an acute triangle. The second type is an obtuse triangle. In an obtuse triangle, we have one angle whose measure is greater than 90 degrees. So let's say this angle was 130 degrees. So we have one obtuse angle and two acute angles, but we would still refer to this as an obtuse triangle. The third case is an equiangular triangle. And that's a triangle where all three angles are equal. So we have three congruent angles. And we'll talk more about this in a minute, but each of those angles would measure 60 degrees. Finally, our last type of triangle according to the angles is a right triangle. A right triangle has one 90-degree or right angle. So sometimes we're asked to classify a triangle by graphing it. So here we're asked to graph triangle ABC with vertices at A, 0, 0, point B at 0, 3, and point C at 4, 0. So first start by drawing your y-axis and your x-axis. And then we'll plot our points. So A is at 0, 0, B is at 0, 3, so 0 for x but 3 for y, so that's why it's up here. And then point C is at 4, 0, so come back to the origin, go 1, 2, 3, 4 to the right, and there's our point C. So connect those vertices to make a triangle, and it says classify the triangle by its sides. And this particular triangle is a 3. That side length is 3, the side length is 4. And if you're familiar with the Pythagorean theorem, that's a squared plus b squared equals c squared, you can solve the hypotenuse, which would be 5. So since none of the sides are congruent to each other, we would say that this triangle, classified by its sides, is scalene. And the second question, part B, determine if the triangle is right. It is, because we can see that the y-axis and the x-axis are perpendicular to each other, and that's how two of our sides in our triangle are formed. So our first theorem for today states that the sum of the measures of a triangle is 180 degrees. Now you may be familiar with this from a previous math course, but we're going to take a few minutes and actually prove it. So we're given triangle ABC, and you see that we've got angles 1, 2, and 3 labeled inside the triangle. And so we're being asked to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So the first thing that I would do in this proof is draw a line BD through point B so that this line BD is parallel to AC. And the reason for that is through a point outside a line, there's exactly one line parallel to the given line. Next, I would probably just draw a little arrow to show that those two are parallel to each other. All right, in step 2, I'm going to talk about how angles add up to 180 degrees in here. So if we take a look, we can say the measure of angle DBC plus the measure of angle 5 is equal to 180. And we can also say the measure of angle DBC is equal to the measure of angle 4 plus the measure of angle 2. Right, and this is by the angle addition postulate. And it's been a while since we've seen that, but the angle addition postulate says that we have two angles that are coming together and forming a third larger angle. In step 3, we're going to use substitution, and we're going to take out the measure of angle DBC and replace it with the sum of angle 4 and angle 2. So we'll have the equation, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. And again, that's by substitution. Okay, next, we're going to use our parallel lines to say that angle 4 is congruent to angle 1 and angle 5 is congruent to angle 3. But we also have to change those congruent statements to equations so we can use substitution. So we'll start off by saying angle 4 congruent to angle 1, angle 5 congruent to angle 3, and that's because if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, also in that same line, take a second and switch it to measure of angle 4 equals the measure of angle 1, measure of angle 5 equals the measure of angle 3. And that allows us to do substitution in our final step. We're going to take out the measure of angle 4 and replace it with the measure of angle 1. We're going to take out the measure of angle 5 and replace it with the measure of angle 3. So then we'll have an equation that says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. And that's by substitution. So what we just proved is that in a triangle, if you take the three angle measures and add them up, their sum always has to be 180 degrees. So let's take a look at two examples for how we can use this. So in this triangle, I see that the three angles are labeled 3x, x, and 60. So I can write an equation 3x plus x plus 60 is equal to 180. So solving that for x, we have 4x plus 60 equals 180. Subtract the 60 from both sides, and we get 4x is equal to 120. And then take and divide both sides by 4. We end up with x equals 30. Now if you take a look at the directions, it says find the value of x, then classify the triangle by its angles. So we have to give it a name according to what kind of angles we have here. So if x equals 30, and we know that this angle is 60, and this angle, 3 times 30, would give us 90. So according to the angle measures, we have a right triangle here. In our second example, we're asked to find x on the outside here, but let's do so by finding the measure of this angle inside the triangle. We know that the three angles in the triangle have to add up to 180, and so far we have 70 degrees and 64 degrees. Take a minute and add those two together, and we find we have 134 degrees so far. So subtract this from 180, and we end up with a measure of 46 degrees. Well, we can answer part of the question, which is to classify the triangle by its angles. Because all of these angles are less than 90 degrees, we have an acute triangle. But we still haven't solved for x. Okay. In order to solve for x, we notice that these two angles form a straight angle. So x plus 46 is equal to 180, or x is equal to 134. Now, if that number looks familiar to you, check it out. The sum of these two angles right here was equal to 134, and that's no coincidence. That's actually going to be our next theorem. The exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, in other words, the two remote interior angles. So what this means is that in our first example, we have this angle marked with x and this angle marked with 45. These two angles are referred to as the remote interior angles. Notice that they are not adjacent to this angle marked with 2x minus 2. So according to our exterior angle theorem, we can take those remote interior angles, add those measures together, and set it equal to 2x minus 2. And now we can solve for x. So I'd probably subtract x from both sides first. And that leaves me with 45 equals x minus 2. Right? And then we want to take and add 2 to both sides. So we get x equals 47. Okay. We're not just asked to solve for x in here, we're actually asked to find the measure of the exterior angle shown. So we want to take our value for x, that 47, and plug it back in here. So we're going to do 2 times 47 minus 2. And 2 times 47 gives us 94. And 94 minus 2 gives us 92 degrees. Okay, just keep in mind that these pictures are not always drawn to scale, okay? All right, in our second example, we should have a little arrow right here saying that this angle is 3x plus 2. Okay. And here we're solving for x. This angle is marked angle 1 as this is our exterior angle. So what we need to do first is solve for x. So keep in mind that the three angles in a triangle have to add up to 90 degrees. So we have x for this little angle. And then we have 3x plus 2. And we have 90. We're going to set this equal to 180 and solve for x. So we have a total of 4x plus 92 equals 180. So that'll leave us with 4x is equal to 88 when we subtract that 92 from both sides. Take and divide both sides by 4, and we end up with x equals 22. But again, remember that you have to go back and answer the question. All right, so if x is equal to 22, then we can just take 180 minus that 22 to find this exterior angle. And 180 minus 22 is going to leave us with 158 degrees. Okay, good luck on the CYU and the homework. And as always, let us know if you have any questions.